Now see, please read question carefully and noted down given data. In simple bend brake, shaft carry a flywheel of a mass 400 kg. So mass is 400 kg. The moment of inertia is equal to 81 kg meter square. So please note I is equal to moment of inertia 81 kg meter square. The flywheel rotates as 300 rpm. So notate n is equal to 300 rpm. Coefficient of friction is 0.2. Coefficient of friction 0.2. Diameter of drum is 240. So diameter of drum is 240 and radius will be 120. So here. Okay. So first determination is torque applied due to load of 100 Newton. We find torque when we applied 100 Newton load. Second determination will be number of turn of wheel before it is brought to rest. And third will be time required to bring it to rest. Okay. So in this case, a flywheel carrying over a shaft of mass 400 kg and moment of inertia is 81 kg. So we know the formula of kinetic energy is equal to half mv square. This formula is used for linear mass transportation. This is the mass of object and v is equal to linear velocity. But in this case, the flywheel rotates at 300 rpm. That means it is in angular motion. In angular motion, we use kinetic energy formula as half I omega square. Here I is equal to moment of inertia and omega is angular velocity. So angular velocity is equal to omega is equal to 2 pi n over 60. This is angular velocity in radian per second. Here I, this is moment of inertia. This is will m k square. So mass of flywheel or mass of rotating body and k. K is radius of gyration. Sometimes radius of gyration noted as k or r. So here in rotation case or angular motion case, the kinetic energy formula used as half I omega square. Here I is equal to m k square. Here k is radius of gyration and omega will be 2 pi n over 60. Okay, now move on to the question. Here from the figure, okay, please see the figure very carefully. Wheel rotates in clockwise direction. P will act at point C. The distance between A and O, this will be 120 and the distance between O and C is 300 mm. So angle between perpendicular disc and direction of T1, this will be 60 degree, or theta angle of lap, the T2 will attach at wheel at point this and T1 will attach at point this. So we assume L and M. The angle between L and M or M to L. So this is point L or this is point M. So this is 180. So this is given as 60 degree. So remaining portion will be 30 degree. So total angle of left theta from L to M is 180 plus 30, that will be 210 degree. Okay, now move on the question. Okay, so first determination is theta is equal to 180 plus 30, that will be 210 degree. This is in degree, but we will use in radian. So by multiplying by pi by 180, sorry, this is not 18, this is 180. So please here, this is not 18, this is 180. Please note it in your notes. Okay, so 210 into pi upon 180, that will give the value of theta as 3.66 radian. Okay, now moves in second. We calculate omega by using the revolution per minute n. So omega is equal to 2 pi n over 60. So putting the value of n as 300 rpm, so we get the value of omega. So omega is equal to 2 pi n over 60 and the values gives as 31.41 radian per second. So omega will be 31.41 radian per second. Now moves for finding kinetic energy. So kinetic energy is half I omega square because this case is angular motion. So half, putting the value of I as 81 and omega will be 31.41. So here will be, please note it here. So in this notes we not used, I think, omega square. So this is 31.41 square. So this is 31.41 square. So we check the values of kinetic energy. Please wait. 1 by 2 into 81 into 31.41 square. Okay. So here square is missing. Only square is missing. The value is correct. The value is correct. So kinetic energy is equal to half I omega square. So half into 81 into 31.41 square. Here is square is missing. So kinetic energy value will be 39956.8. 39956.8 Newton meter. Okay. Now moves on. We know limiting ratio of tensions T1 upon T2 is equal to e की power mu theta. Putting the value of mu as 0.2 and theta as 3.66. So we get the value of T1 upon T2 as 2.7. The ratio of tensions T1 upon T2 is 2.7. Now take the moment about point O. Take the moment about point O. So P into 300, it makes a clockwise couple. So P into L, it's make a clockwise couple. Second couple is T2 second couple is T2 into this distance, it's make a anti-clockwise couple. So both couples are in opposite direction, the sum of moment will be 0. So P into L minus T2 into 120 equal to 0. So we know the value of P, that is 100 Newton. So P is 100 Newton into 100 into 300. So 100 into 300 equal to T2 into 120. 100 into 300 into T2 into 120. So by using this relation, we got the value of T2. The T2 will 250 Newton. The tension in slack side will be 250 Newton. Put the value of T2 in tension ratio. So we get the value of T1. So we know T1 upon T2 is equal to 2.7, 2.07. So here we got the value of T2. So putting the value of T2 in this equation, so we got the value of T1. So T1 here is 517.05 Newton. So we got the value of T1 and T2 and kinetic energy. So now move on finding the braking torque. So braking torque is equal to force into radius of drum. So force will be T1 minus T2. So braking torque will be T1 minus T2 into R. So putting the value of T1 minus T2 and radius of drum. So radius of drum will be 120 mm. So putting the value of T1 and T2 into R in this equation, and we got the value of TB, braking torque. So braking torque will be 31.1 Newton meter. So braking torque will be 31.1 Newton meter. I think this is first determination. In first determination, applied torque due to load 100 Newton. So we got the braking torque 31.1 Newton meter. Now move for second determination, numbers of turns or numbers of revolutions of wheel before it is brought to rest. So we see in simple block brake conditions, when wheel becomes to a rest position, the work done or kinetic energy will be equal when wheel takes come into rest position. So we find work done because here kinetic energy we find it, so we calculate work done for second determination. So here we calculate work done. Work done is equal to force into displacement or displacement in terms of distance traveled by wheel. So here please see. So we assume x is the displacement or distance traveled by wheel. So in previous lectures we see x as distance traveled by wheel as or equal to circumference of wheel and numbers of revolution required, that will be distance covered or distance traveled by a wheel. So circumference is equal to pi into d and numbers of revolution required, that will be small n. So small x is equal to pi d into n. Okay. So we also know the force is equal to T1 minus T2 and T1 minus T2 into R is equal to B, TB. So T1 minus T2 into R will be TB. TB will be braking torque. Now see here. So work done is equal to force into x. X is distance traveled by wheel. That's value will be pi d into n. So putting the value of x here and putting the value of force T1 minus T2 here, and we got the formula of work done T1 minus T2 into pi into d into n. Here 2r is equal to diameter. So d is equal to 2r. So T1 minus T2 into r, that will be braking torque, and remaining portion will as noted down. So work done is equal to Tv into 2 pi n. Okay. So we get the value of Tv from here. Okay, and putting the value of Tv from here to here. So putting the value of Tv in this equation, so we get the value of work done as 201.69 into n. 201.69 into n. For wheel we come into the rest position, the work done will be equal to kinetic energy. So work done will be equal to kinetic energy. Here we know work done and here we know kinetic energy. So work done will be equal to kinetic energy. So 201 into n equal to 39956.8. So here we calculated n. We calculated n as 198.10. That is equivalent to 198 revolution. So here we got the value of n, 198 revolution, and this is the determination of second. Numbers of turns or numbers of revolutions, that will equal to 198 revolution. Now in third determination, time required to bring the rest. So time required. So we know the n. N will be as 300 rpm. So 300 rpm means 300 revolution in a single minute. So here 300 revolution done in 1 minute. So 1 revolution done in 1 by 300 minutes. So here 198 revolutions. For 198 revolutions takes 198 upon 300 minutes. That will equal to 0.66 minutes or 39.6 seconds. Here. So time required to bring the rest 0.66 minutes, and we multiply by 60 in 0.66. So we get the value of 39.6 in second. Finally, we get all determination. For determination of torque, so torque will be 31. In first determination, torque will be 31.1 Newton meter. Second determination, numbers of turns or numbers of revolution, that will equal to 198 revolutions. And third determination is time required to bring it rest, those time required for 0.66 minutes or it's equivalent to 39.6 seconds.